ZenConnect Bangalore is brought to you by JLL, Lend-Lease, and is powered by Unissu. Amarjeet Singh discusses IoT-powered digital infrastructures and incremental journey.
Hello, I am Amarjeet Singh. I am the co-founder and CTO of Zenatix Solutions Private Limited, an IoT company that is part of a multi-billion-dollar hero group. Today, I will be talking about IoT-powered digital infrastructure and how you can take this digital journey in an incremental fashion. The broader mandate is to invest into and help grow technology companies that can contribute towards a connected future. Mandate for Zenatix is to give IoT solutions for broader enterprise SaaS segment. So what do we really offer? Our solution ZenConnect retrofits existing buildings all the way from small retail stores to large buildings by instrumenting them with wide variety of sensors. These sensors include energy meters, temperature sensors, humidity sensors, luminosity sensors that then wirelessly communicate to a centralized gateway which is in-house developed through our R&D team and is open and rugged. That gateway then communicates to the cloud platform using cellular, Ethernet, or Wi-Fi. Millions of data points are collected in this fashion that feed into our AI algorithms that can give useful insights for operating these buildings in a green fashion. These insights are of wide variety. You get a centralized visibility into how each of your buildings are performing. Data is collected at each and every asset level to give you predictive and preventive maintenance, essentially telling you when do you need to service which of your thousands of assets and what exactly is to be serviced. On top of that, with automated control and intelligent control, you get energy savings which largely pay for the solution. This ZenConnect solution is deployed across a wide variety of verticals ranging from a small 2,000 footprint retail store that could be a quick service restaurant, a supermarket, or a clothing retail, to a large 200,000 square feet building that could be hotel chains or a chain of office buildings. Over these years, we have built a holistic approach to provide connectivity in the built environment. Our in-house R&D team understands the end-to-end IoT infrastructure very well. And our analytics team has both the domain expertise as well as the statistical and the machine learning knowledge. The software is built with quality and security first mindset. We also work with our customers to set up a collaborative center of excellence so that the data that is being collected can be used for business competence and competitive leverage. This is our small bit to contribute towards a sustainable future and by contributing towards the 3 E's, namely energy, environment, and equipment. Let's understand what are the challenges for digitizing the built infrastructure. There are largely 2 types of built infrastructure: the large buildings, which are 100,000 square feet or larger, or the smaller footprint like retail stores or supermarkets, etc. When it comes to large buildings, we already have building management solutions. They have been in existence for decades, but they are now very archaic. They work on a wired infrastructure when today all of these large buildings already have a wireless infrastructure within them. The installation is very hard to do, very cumbersome, and requires skilled manpower, and therefore is very, very expensive to not just deploy, but also to maintain. On top of that, because you have hundreds of these sensors which are deployed across the building, if you are not collecting the health of these assets, you have zero visibility into how each of these sensors and control points are behaving, and therefore their maintenance also becomes a tricky thing. These building management systems are collecting huge volumes of data, but what are they using that data for? Only simple threshold-based control. This huge volume of data can actually be used to create intelligent algorithms for intelligent control, which these building management systems are not doing. When it comes to small footprint store, typically a chain for a quick service restaurant or a clothing outlet would have hundreds or thousands of these stores deployed across multiple geographies. There is typically zero visibility into what is happening at each and every store. Tens of thousands of your assets spread across these stores are very hard to then maintain. On top of that, there are manual operations that are happening, and therefore ensuring that there is compliance across all of these stores is just not possible. A very expensive building management system is just not affordable for such small footprint stores, and the numbers speak for themselves. Even in a developed economy like the US, for buildings that are less than 50,000 square feet, only 2% of them have building management system. And that is where the opportunity lies. If you can create an IoT-based connected infrastructure, then you can not just disrupt the building management systems for the larger buildings, but there is a huge market of small footprint properties which are just left unattended by these building management systems. Internet of Things, or IoT as it is commonly known, is really disrupting the way building management systems are used in built properties. Recent advancements and technologies in IoT is changing the way the built infrastructure is to be managed, not just the large buildings, but even the small footprint stores. I'll today talk about 3 such technologies that have recently come up and have a huge potential to disrupt the way the buildings are to be managed through a connected and digital infrastructure. The first such technology is a wireless, low-power mesh. While ZigBee has been in existence for many years, its proprietary nature didn't let it go for a widespread adoption. It's only recently that Bluetooth came up with its open source version of BLE 5.0 mesh, and Google also open sourced its Open Thread mesh. Together with these 3 mesh, a lot of now chipset manufacturers are coming up with chipsets that support multiple of these protocols on the same chipset. Now imagine you can throw in these battery-powered sensors anywhere you really want without disrupting the aesthetics of your built environment. The data that you collect will help you analyze and benchmark the assets that you really want to monitor and control without worrying about running cables to connect these sensors. The instrumentation of these sensors is also very simple and doesn't require any expert labor, and therefore reduces the cost for installation. So together with lower cost of hardware and lower cost of manpower to install and maintain, these are really disrupting the way sensing and control happens in the built environment. The second such technology are open and modular Linux-based gateways. Zenatix has also built some such gateway based on a Raspberry Pi compute platform, which can be extended to support multiple protocols that are commonly found in a built environment, such as Modbus, CAN bus, BACnet, etc. These gateways also talk over wireless low-power mesh to all of these sensors that are spread across the built environment and provide a rugged and reliable industrial-grade internet connectivity over Ethernet, Wi-Fi, or cellular. These gateways come with remote VPN connectivity, and therefore you don't really need to go physically to them to troubleshoot if there is any problem. Again, not the way the hardware gateways in building management systems are typically managed today. Third such technology is a generic and extensible wireless control node. If you look at different control points within your built infrastructure, they are typically either 4 to 20 milliamp control point, 0 to 10 volt control point, or analog or digital control points. If you have a generic node that can support these control points, again over the same low power wireless mesh, you have an infrastructure whereby you are collecting data on this low power mesh, and you are also enabling control of these assets over this low power wireless mesh. There is no need to run hundreds or thousands of meters of cable, and thus maintaining this infrastructure is also super easy. What this is enabling is that a combination of these wide variety of low power wireless sensors, a common and extensible wireless control node with an extensible gateway that can support multiple protocols, you can now manage possibly all different types of assets. Air conditioning, be it water side air conditioning or VRF or VRV based air conditioning or ductable AC controls, or even small space units which are sort of split units or rooftop units. You can even connect your other assets like fire alarm to ensure that the safety of the occupants within the building is maintained. Let's now understand how this digital journey can be taken in an incremental fashion. First, let's just take a simple case of buildings that already have a building management system. Like I mentioned earlier, because these building management systems are already collecting millions of data points, it is now about connecting these data points to a cloud infrastructure where you may run your advanced analytical algorithms to perform fault detection and diagnosis, to also perform intelligent control beyond basic threshold-based control. So essentially, you start leveraging the huge volume of data that these BMS systems are generating but are not using at all. Now let's look at the other side, the built infrastructure that does not have an existing building management system. That is largely true for all small footprint stores, and also largely true for even larger buildings in developing economies. In such a building, my recommendation would be to live this digital journey in an incremental fashion. At the first step, you may only instrument basic energy metering at different feeder level and also perform ambient sensing, be it temperature, humidity, or luminosity. With this basic sensing in place, what you can then do is you feed that data into your machine learning algorithms that can then do fault detection and diagnosis and automatically create tickets for your different assets within the built infrastructure, be it multiple assets within one infrastructure or thousands of assets spread across your thousands of built infrastructure which are spread geographically. These tickets then automatically get generated, feed into your maintenance team, and now you can even monitor digitally sitting at a central location how your maintenance team is performing, not just at the team level, but how each individual is performing within that team, and are your assets being maintained properly or not. There is, of course, the other side of proper maintenance of these assets, because that what you want to eventually ensure is the safety of the occupants of your building and also ensure that the occupants are comfortable. You also want to ensure that the assets that you are maintaining, for example, your perishable items in the refrigeration units, are all maintained at the right temperatures so that you are compliant as per the regulatory frameworks. All this is easily done even when you don't have a building management system and you do basic energy metering and ambient monitoring. As a next step, you can take this basic sensing to control and actuation for the endpoints which are easily controllable. So in a large building where you have a water side and an air side system, you only then focus on controlling the air side. For example, you focus on controlling the air handling units. Or if you have controllable VAVs, you focus on controlling those VAVs only. In this perspective, you may install VFDs on your AHUs to control the fan speeds as well. If you have a ductable unit, control that ductable unit. If you have a split unit or a RTU, start controlling those units. With this basic control in place, which is connected to the cloud infrastructure, together with the detailed energy metering and the ambient sensing, you can now not just perform time-based control, which your typical building management systems give, but also much more intelligent sensor-based control, which are driven by how is the weather outside, number of people in the building, and so on and so forth. As a third step in this journey, you can now start connecting various other software systems that you may have within your built environment. For example, you may have a CAFM system, you may have a different surveillance system, you may have a different access control system, and each of these systems are otherwise working in silos. What you can do is to interconnect all of these systems so that the data that you get by interconnecting these systems can then be leveraged to do better intelligent monitoring and control, which is otherwise not possible by each of these silos that were otherwise created. And as a final step in this journey, you can dream of achieving what the full building management system would give you, whereby you start then monitoring your elevator systems, you start controlling your water side and more complex systems like your chillers, and you also start integrating other non-essential assets like pumps, etc., to get you better visibility about your assets. So essentially, unlike when you bring in a building management system, you have to do all of these things together and pay a huge upfront investment. You can actually do this digitization in small steps, look at the ROI at each and every step, and then decide whether you want to really invest and move forward to the next step or not. At each and every step, there are companies like Zenatix that can give you very interesting business models where you don't even need to invest into the sensing and the control technology, and all you do is sort of a pay per square feet kind of a recurring model. And we do all the investment and we guarantee the benefits that we are all talking about. So in summary, building management systems have been in existence for more than 3 to 4 decades, but they were largely focusing on the control. Their data was never appropriately utilized. They had a huge upfront cost, and therefore the ROI didn't make sense for buildings that are smaller than 50,000 square feet. Recent advancements in Internet of Things are disrupting this whole BMS systems, not just for the large buildings where there is huge opportunity in developing economies, where very few buildings have these BMS, but also a huge gap of small buildings which is globally unaddressed by these BMS systems because they are completely unaffordable for that class of properties. And you don't need to live this journey in one full go. You can live this digital journey in an incremental fashion. And over the last 6 years, we have built technology and we have created interesting business models that can help you live this journey step by step in an incremental fashion and contribute your bit to the sustainable future.